Hi, Kim peeps. I am going to talk about VSEPR shapes for molecules. And we know they're molecules because they have nonmetals bonded to nonmetals with covalent bonds. And these are 5 basic shapes that we would have when molecules bond. The first one is linear, and we call it linear because the shape is straight across and the angle between the bonds is 180 degrees. The next one is trigonoplanar, and planar meaning flat. So if I could build this with my model kits, it would lay flat. All 4 of these balls would lay flat on the tabletop, and the angle between the bonds is 120. Tetrahedral, tetra means 4 in Greek, and if I built this, it would actually, the bottom 3 balls would sit on the tabletop and the top one would be sticking straight up. So I know it looks two-dimensional here, but three-dimensionally, the angle between here is 109.5 degrees. The next one down here below is trigonal pyramidal, and these 3 white atoms or balls would sit on the tabletop and form like a pyramid with the blue up in the air. And I have represented something that we don't see in the model, but the reason that the 3 atoms at the bottom are pushed down is an unshared pair of electrons. So in other words, they're not participating in any bond. There is some extra repulsion from these electrons which push these down, and the angle between the bonds is 105 degrees. And finally, our last one is bent. Bent is going to have 2 unshared pairs of electrons. We don't see that when we build this, but it is really bent in shape. And so the angle here is a little less than 120 degrees. Okay, follow me on TikTok and YouTube at Kim's Kim Chats for more on Lewis dot structures, and I hope this helps.